Hey everyone, this mini lecture's on moles. I think I'll just cut to the chase to start with and tell you what a mole is equal to. It's equal to 6.02 by 10 to the 23. Now you're probably going to ask yourself the question, 6.02 by 10 to the 23 what? And the answer is nothing. It's simply a number. And it's a very, very large number. As you can see, it's more or less 6 followed by 23 zeros. The number is actually huge, unimaginably so. We use it in chemistry to count up groups of atoms and molecules because they're so small. And when you count them up into these groups called moles, they're much easier to deal with. The best way to explain this is to go through this lecture with you and show you by example, but at least it gives you an idea of where we're heading with all of this stuff. Alright, let's continue on. Alright, I think I've kind of alluded to this already. When you're weighing things out in the laboratory, you're going to weigh things out in things like grams, quantities, etc. You certainly can't weigh anything out that's on the level of atomic mass units. As I pointed out in a previous mini lecture, atomic mass units are incredibly small measurements of mass and really don't lend themselves to any sort of measurement at all. Hence the need for this thing, as I said before, the mole. Okay, I've made those points there, and of course then if you've got very, very small things but you gather them up into bunches, then of course collectively those things are measurable, i.e. the mole. I just point out to you too that the mole is sometimes called Avogadro's number, and in chemistry we basically use the mole like in everyday language you'd use the term dozen. So if I said to you I'm going to get 2 dozen eggs, you wouldn't even think of asking the question, well, how many eggs are you going to get, because you know the answer is 2 dozen or 24, it's one and the same thing. So in chemistry, if I say you've got a mole of stuff, it means you've actually got 6.02 by 10 to the 23 of that stuff. Now this last point here is a little bit buried. I should have put this up in flashing neon lights because it's extremely important. It just so happens that if you have a mole of a substance, then its atomic mass then corresponds to the mass of 1 mole of that stuff in grams. So to give you an example, if you look up the atomic mass of carbon, it's 12 atomic mass units, which means that if I have 1 mole of carbon, I will actually have 12 grams of carbon. Or, if you want to look at it the other way around, if I've got 12 grams of carbon, I must have 1 mole of carbon atoms. Or, if I had 6 grams of carbon, I must have half a mole of carbon atoms. I think you can start to see the use of moles. Just in case you can't, and I know there's students that get a little bit freaked out by this number, again I want you to start thinking of a mole a bit like a very large unit of collective measurement, like a dozen. So if I said to you that I've got a bunch of people, a dozen of them in fact, and their average weight is 70 kilograms, I don't think you'd have any trouble calculating what their collective mass would be. You'd say it would be 70 multiplied by 12. But now you should be able to do the same thing with a mole. If I ask you that question, how much does a mole of people weigh, assuming that on average they weigh 70 kilograms, the answer is going to be 6.02 by 10 to the 23 multiplied by that 70 kilograms there. If you ask this question, how many oranges do I have if I have 3 moles of them? Well, you might in fact just answer back that I've got 3 moles of them, because you know obviously what a mole is. But I think implicit in this question is the question's actually asking you what are the number of units involved when I'm talking about 3 moles, and of course the answer would be 3 multiplied by 6.02 by 10 to the 23. Okay, well then you can, let's go from the macroscopic to the microscopic. If I ask you this question, how many carbon atoms do I have? If I have 1 mole of carbon atoms, well, the answer is 1 mole, or you could say I've got 6.02 by 10 to the 23. But now, because we also know that other trick, that the mass of an atom expressed in grams will correspond to 1 mole of that particular group of atoms, then I know if I've got 1 mole of carbon, I can look up the atomic mass of carbon in the periodic table. You'll find that it's 12 atomic mass units, which means that I've got 12 grams of carbon, because 1 mole of any of those substances expressed in grams for their atomic weight will be in fact that particular mass. Okay, so this one here is a little bit trickier. What is the molar mass of oxygen gas? So for that one there, I just grab my pen for a sec. I'll do it in red. Oxygen gas, as you know, gets around as O2, so there's actually 2 atoms of oxygen gas in each molecule. So and if you look up the atomic mass of oxygen, it's 16. So I've got actually 16 plus 16 equals, that's terrible, 32. Sorry about the writing. And 32 watts? Well, if it's the molar mass, instead of writing AMUs here, it would be grams. That's it. That's simple. Alright, so just showing you another calculation. So with this example here, how many formula units? We're talking about an ionic compound here, copper sulfate. How many formula units are there in 3 moles of copper sulfate? Obviously you can't use the word molecules because there are no molecules in this ionic compound here. Well, the number of formula units would be, well, there's 3 moles, so it's 3 moles multiplied by 6.02 by 10 to the 23, and there's that many formula units per mole. You can see here that the moles cancel themselves out, and you're left with that is the number of formula units. So it's very easy to work this out once you get used to it. Okay, now we can start calculating molar masses of things. So if I said to you, what's the molar mass of copper sulfate? This is the way you would do it. So you go to the periodic table. Here's a little excerpt here. The formula for copper sulfate is CuSO4. I've got 1 copper. So if I look up copper there, it's a little bit messy there, but that says 63 point, let's make it 55 grams. So the molar mass of copper is 63.55. Now it's grams per every mole. So that would be the proper units. If you look at the sulfur, it's about 32 grams per mole. There it is there. Now oxygen, I've got 4 of them, but we'll just write down the first one to start with. Oxygen's pretty close to 16 grams per mole. So the molar masses of the respective elements that make up copper sulfate are now written down here for the solution. Okay, so what's the molar mass then? You just add them up. So we've got 1 copper, so 1 times that amount, 1 sulfur, that amount there, and 4 oxygens, so it equals 160 grams per mole. Note the use of the units. It's most important that you get your units right. Alright, the other thing we can do is actually convert moles and mass, because obviously you can't actually measure moles directly in the laboratory. You're actually measuring out the mass of things, but we can then figure out how many moles we've got. So how do we do that? Well, we use this formula here. So we work out the number of moles by, first of all, figuring out what the mass is. So we weigh it, in other words, and then what we do is we calculate the molar mass. How do we calculate the molar mass? Just like I showed you before in that previous slide with copper sulfate. Okay, so here's an example. How many moles are there in 150 grams of copper sulfate? So again, we go through this process of working out the, oh sorry, not copper this time, calcium. So we go through the process of working out the molar mass of calcium sulfate. Okay, we've got them all there. Now we can see here that the total molar mass is 136.2 grams per mole. We use that formula there and then we just simply plug it in. So the mass was 150 grams, the molar mass is 136.2 grams per mole. So the number of moles is there. The answer popped out before and it should have. It's 1.1 moles.